Welcome back, students. In this video, we're going to cover Module 7, Topic 4, rectangles. This is page 10 of the Module 7 packet. Start out with the warm-up here. It's going to say find the unknown measurements, measures for the parallelogram. So, back to the last couple of videos. So, JK. The JK, that's over here. Well, if this thing's a parallelogram, the opposite sides are congruent. So if that's 15, that's 15. Angle J is over here. Now these two, if this is the parallelogram, these guys are going to be supplementary. So J is going to be 180 minus 71, which is 109 degrees. All right, angle L. Angle L is opposite of J, so if J is 109, L is 109. KL is opposite IJ or JI, which is 21. So this guy's 21. And then the measure of angle K, that's opposite I, which is 71. So this one also is 71 degrees. All right, moving down. Let's see, just a second. There we go. All right, so properties of rectangles. A rectangle is a parallelogram with 4 right angles. To name a rectangle, use the symbol, rectangle there. From the definition, you know that a rectangle has the following properties. All 4 angles are right angles. Opposite sides are parallel and congruent. All angles are congruent. Well, they're all right angles, so they all have to be congruent. All angles are supplementary. Well, 90 plus 90 is 180, so yep, that's true too. And then the diagonals for these guys bisect each other. So in addition, the diagonals of a rectangle are congruent. So that's what separates it. It is a parallelogram, but it's a special parallelogram. So keep this in mind. Theorem 7.13, diagonals of a rectangle. If a parallelogram is a rectangle, then its diagonals are congruent. So we'll say it twice because it's important. So now let's scooch down the page. All right, practice problem number 1, page 10, bottom of the page. A basketball team is running a drill along the diagonals of the court. Given that rectangle BCDF, if FC is 106 degrees, 106 feet, 106 and a half feet, geez. So FC, this whole diagonal is 106 and a half feet. Find DG, so they want half of it. Well, if the diagonals are congruent, that means if FC is 106 and a half, this whole thing's 106 and a half, so in this case DG is going to be 1/2 of that, and 1/2 of 106 and a half feet is 53.25 feet. Let's flip over to page 11. Excuse me. All right. Page 11, number 2. Quadrilateral ABCD is a rectangle. If the measure of angle BAC, so BAC, that's this guy, is 3x plus 3, and ACB, so down here, this guy is 5x minus 1. Find the value of x. Okay, well, one thing. So if this is a rectangle, we have 4 90-degree angles that are cut in half by these diagonals. So these guys are, yeah, they're congruent, but they're complementary. They equal 90 because they're both half of a 90-degree angle. So find x, we're going to say that 3x plus 3 plus 5x minus 1 equal 90. So we got 3x and 5x, which make 8x. 3 minus 1 is positive 2. Subtract 2 from both sides. 8x equals 88. X equals 11. Excuse me. All right. Number 3. Quadrilateral JKLM is a rectangle. It says find the measure of angle JNK. So right here is 5x plus 2. And J, let's do it this way. JNM is 3x minus 6. It says find JNK, and JNM. Well, first off, notice both these guys are a linear pair. A linear pair equals 180 degrees. They're supplementary. Actually, let's not use that. Let's use this one. So, in this case, 5x plus 2 plus 3x minus 6 equals 180. So 5x and 3x make 8x. 2 minus 6 is negative 4. So we're going to add 4 to both sides. X is equaling, handy dandy, notes from earlier, 23. Excuse me again. All right, so x equals 23. They want to know what both of these angles are. I really got to get my calculator out. So if we plug in, so 5x plus 2, if 5 is 23 plus 2, 5 times 23 is 115 plus 2. That's going to be 117 for, and this is angle JNK. Okay. Excuse me, I'm sorry. And then for the other angle, just go up here. Excuse me. 3x, or 3 times 23 minus 6. So 3 times 23, 9 is, let's see, 69. Minus 6, that's 63 degrees. And that is the measure of angle J. What is that? JNM. And of course, 63 plus 117 equals 180. So that's how we know we're right. All right, moving down the page. Number 4. Quadrilateral JKLM is a rectangle. If MN, so that's this piece, is 3x plus 1, and JL, so that's the whole line. Actually, so I'm going to highlight it. So JL, and it's going to be 2x plus 9. Find MK. So MK is the whole thing. Round to the nearest tenth if you need to. All right. Excuse me. So, in this case, because it's a rectangle, the diagonals are congruent. So that means that JL is congruent to MK. So we're going to have to solve for x first to do this. So in this case, because we have x here for MN, let's just do it like this. So MN, because these guys are congruent, MN's half of that. MN is equal to, let me think, no, 2 times MN is equal to JL, because it takes 2 of these to make one of those. So now we just plug in. So 2 times 3x plus 1 equals 2x plus 9. So we distribute the 2 first. 2 times 3 is 6x. 2 times 1 is 2. 2x plus 9. Subtract the 2x from both sides. 6 minus 2 is 4x plus 2 equals 9. Subtract the 2. 4x is going to equal 7. Divide both sides by 4. X is 7/4. Or, what is that? Well, we'll get back to that in a minute. All right, so 7/4 now. So we're just going to, how are we going to do this? All right, so it was 2 times mn was going to give us mk. So we're going to plug our, what did I do here? Okay, yeah, sorry. Couldn't figure out what I did. So 3 times x, or so 7/4 is also 1.75. Sorry, I lost my train of thought, guys. So 3x plus 1 equals 6.25. Excuse me. So now, this is mn. Mn is 6.25. Mk is 2 of that, so 2 times 6.25 is 12.5. So mn equals 12.5. Hope I didn't lose you guys in that. Sorry, it got a little squirrely there for a minute. Okay, moving down. Diagonals of a rectangle. You've learned that if a parallelogram is a rectangle, then the diagonals of a parallelogram are congruent. The converse is also true. So for 7/14, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So just the opposite of what we said a moment ago. Excuse me. Can't get to the mute button fast enough, guys. Sorry. All right, number 12. I'm sorry, page 12. My goodness. It's been a long day. Just move my camera. I'm off the table here, just having a hard time. I'm sure you guys are just enjoying this. Give me 1 second. Okay. So, page 12. Number 5, complete the proof with the correct statements. All right, so supposed to have a word bank. We didn't have one here, so I'm just gonna give you guys answers. Try to show you as we go. So I'm hoping that you'll learn. So when you have a word bank, maybe it'll be a little easier. So I want us to complete the proof. Given that this guy's a rectangle, and they tell us that PT and ST are congruent. So if this guy is a rectangle, that's really what this proof is going to be. So we're just going to go through here and express it and talk it out. So number 1, PQRS is a rectangle, PT and ST are congruent, and that was given. Number 2 says PQRS is a parallelogram. Well, that's the definition of a rectangle. A rectangle is a parallelogram. It's a special parallelogram. All right, number 3. So the reason is opposite sides of a rectangle are congruent. Well, the opposite sides of this guy are QP and RS. So QP is congruent to RS. And why? Because opposite sides are congruent. So let's just do this. Notice I didn't go here, but we've already got something going on here, so I figured I would just pick those opposite sides. All right, number 4 says the definition of a rectangle. So let's see, what else do we have? Well, remember I said that the rectangle is a special parallelogram. What makes it special? It's because it has 4 right angles. So angle P and angle S are right angles. All right, number 5. So we also had S and P under us here. So if S and P are both right angles, S and P are congruent. And why? Because all right angles are congruent. So if you kind of talk this thing out, you can get there. Or if you'd look below, so S and P are congruent, they're both right angles, well, make them right, and then come up here and all right, P and S are right angles. Okay, so number 6. So the 6 is SAS. That's side angle side. So we're talking triangles, right? So these two triangles are congruent because if they're right angles, this is leg leg. But side angle side works because it has a side, it has an angle, and it has a side, an angle, and a side. So we're gonna just put it QPT RST. So triangle QPT is congruent to triangle RST. And then CPCTC, so corresponding parts of congruent triangles are congruent. Well, they asked us to prove that, let me scooch down, that QT is congruent to RT. So that's what we're writing here. Now, we're proving that because, let me just find another color. So this triangle and this triangle are congruent. Well, side, angle, side, this side, QT, and RT are both congruent because corresponding parts of congruent triangles are congruent. All right, moving down. Number 6. Quadrilateral GHJK has vertices, and it lists those, and I've got them written down. Determine whether this parallelogram is a rectangle by using the distance formula. So we're going to use the distance formula to see if the opposite sides are congruent. So let's start with GH, and we'll do let's see, I'll do every other one blue and red here to try to keep the confusion down. So we know the distance formula is the square root of x sub 2 minus x sub 1 plus y sub 2 minus y sub 1. So just a moment, I find my sheet here. Just want to make sure I'm not off in left field. So pardon me one moment. Yeah, okay, just making sure. Okay, so GH, we have negative 3 minus 3 squared plus 0 minus 2 squared. We'll take this down. Negative 3 and negative 3 make negative 6. 0 and negative 2 make negative 2. Just going to take these over here. We square negative 6 and we have 36. We square we square negative 2 and we have positive 4. So GH is going to be the square root of 40. Alright, I probably should have done this different. That's okay. Alright. So over here, we got KJ. That's these two together should equal, and the bottom two should equal. I'm probably going to run out of space, but we'll do the best we can. So KJ, our x's are negative 2 minus 4. Sure you got that right. Yep. And the y's are negative 3 minus negative 1. Yes. Okay. So negative 4, negative 2 make negative 6. Excuse me. 3 minus negative 1, that's like negative 3 plus 1, which is negative 2. Excuse me, I'm sorry. So notice these guys are like these guys. So we got negative 30, we got 36 and 4 again, which is the square root of 40. So these guys check out. Now let's do this. So for GK, it's going to be -3 minus -2 plus 0 minus 3. I'm sorry, 0 minus -3, so 0 plus 3. -3 minus -2, so that's -3 plus 2. That's -1 squared plus 3 squared. -1 squared is 1. 3 squared is 9. 9 plus 1 is square root of 10. All right, and then over here for HJ, our x's are 3 minus 4. Our y's are 2 minus -1. All right, that's kind of messy, but hopefully you guys are listening and not just pausing and taking notes. So 3 minus 4, -1 squared, plus 2 minus -1, so that's 2 plus 1. That is 3 squared. 1 squared is 1. 3 squared is 9. Look where we're going, square root of 10. So, yes. I'm just going to say yes, it's a rectangle. Sorry, we're out of room. So, yes, it's a rectangle, and that's because both sides, our opposite sides, are congruent. You guys are going to be so mad about how much I'm asking you to write, but I promise it'll help you. All right, number 7, bottom of the page. This concludes topic 4 as soon as we finish here. So a quadrilateral has vertices. A is 2, 6. So 2, 6 for A. B is 3, 7. 3, 7. C is 6, 4. 6, 1, 2, 3, 4. Which of the following points would make this a rectangle? So we're not going to do all the math. It would make the video and the writing a lot longer. Notice these guys line up. If you don't have my ruler, nope, yes I do. I have my. Here we go. So we've got my straight edge right here. If you go like this, you go like this, it will, let's see, hold on, let's measure. We're going to measure that, and then it's going to put us like right here. So let's see what choices we have. D could be at 5, 3. So let's see, 1, 2, 3, 4, 5. 1, 2, 3. Ah, jackpot! Look at that, first try. It's like I've been doing this or something. All right. I know this doesn't look right. It is, I promise. Ugh. You guys know I can't draw, but I promise you that's the real answer. All right. Any questions, let me know in class. Until next time, have a great evening.